Assalamu alaikum dear students. This is our next problem. Problem having been once again chosen from the book Modern Physics by Kenneth S. Crane. Dear students, basically this problem relates with black body radiations. As usual, we first come towards its statement and then we will go to helping tools and then we will come to its solution in a proper manner. Okay. A cavity is maintained at a temperature of 1650 Kelvin. Okay. As I have once or twice mentioned earlier that whenever we use centigrade or Fahrenheit, we use degree, but in Kelvin scale we do not use degree Kelvin. Okay. A cavity is maintained at a temperature of 1650 Kelvin. At what rate does energy escape from the interior of the cavity through a hole in its wall of diameter 1.00 millimeter? Okay, here mm stands for millimeter and milli in terms of mathematical language stands for 10 raised to the power minus 3. Okay, 10 raised to the power minus 3 stands for milli, while 10 raised to the power plus 3 stands for kilo. 10 raised to the power minus 6 stands for micro. 10 raised to the power plus 6 stands for million or mega. 10 raised to the power minus 9 stands for nano, and 10 raised to the power plus 9 stands for giga. Anyhow, this sequence at least goes up to 10 to power 24. Okay. Here students, one thing needs to be noted that whenever we use the term rate means rate of doing work. Okay, moreover, here diameter is given, which is 1 into 10 to power minus 3 meter. Okay, we will see whether diameter is fixed in the formula or radius is fixed in the formula. If radius is fixed in the formula, then we will take half of the diameter. Okay, we know that radius is equal to d by 2, half of the diameter. Moreover, dear students, one thing more becomes here relevant that there is a two-dimensional quantities as well as three-dimensional parameters. Okay. For example, area of a circle is pi r square, while area of a sphere is 4 pi r square. Okay, so we will also discuss this thing. Anyhow, first we come towards its helping tools. These tools will make a clear guideline for us to be adopted, okay, to reach its final solution. Okay, first tool is a formal definition of Stefan Boltzmann law for a black body. Okay, what? Stefan Boltzmann law for a black body. Okay, this law states that I is equal to sigma T raised to the power 4. T temperature in Kelvin. Okay, here I is the intensity of radiation from black body. Sigma is Stefan Boltzmann constant. Because we are here defining Stefan Boltzmann law, so if we remove this constant sigma, then we can say that I is directly proportional to 4th power of absolute temperature T. Okay, I is directly proportional to t raised to the power 4, but here sigma changes the sign of proportionality into equality, and hence this constant is called Stefan Boltzmann constant, and this is sigma. In Greek alphabets, this symbol is called sigma. Okay, we will also introduce a tool in which this thing will be clarified, clearly mentioned that this symbol is pronounced as sigma. Okay, dear students, actually the purpose of introducing these tools is to develop a sense of confidence. Okay, in those students who for one reason or the other are not in regular touch with their studies. Okay, suppose we say that they have restarted their education after some gap. Okay, no doubt this situation occurs very rarely. Mostly students continue their education in a proper line and discipline. Okay, but unfortunately, because I had about 8 to 10 years gap in my study of physics and mathematics. Okay, in these 8 or 10 years I had studied other subjects like law, LLB for 6 7 years. Then I also started MA English for a few months. Anyhow, so due to this gap, this trend has developed in my learning mode, that I always collect study material so that this study material may develop a confidence in my thought or intellectual approach, that I am pronouncing something correct, or I am using some symbol correctly. I know that symbol correctly. Okay, intensity of radiation from black body I is equal to Stefan Boltzmann constant sigma into T raised to the power 4, where T is the absolute temperature of black body. Okay, when we use the term absolute temperature, it means we are not taking into consideration degree centigrade or Fahrenheit degree, Fahrenheit degree or degree centigrade. Okay, absolute temperature means Kelvin. Okay, tool number 2. A point source of electromagnetic waves emits the waves isotropically, that is, with equal intensity in all directions. The intensity of the waves at distance r from a point source of power Ps, where S is written as a subscript of P, is I is equal to Ps over 4 pi r square. Okay, dear student, this tool will only be helpful in solving our problem, but here the situation is that in case of point source, in this case we are taking 3-dimensional situation. Okay, so here a radius of a sphere is involved, but we are concerned with the hole in wall, meaning 2-dimensional. So we are concerned in our problem with the area of a circle, which is only pi r square. Okay, okay, 2-dimensional and 3-dimensional. In our current problem, we are dealing with 2-dimensional situation in which area of a circle is relevant. This similar situation deals with a situation where 3-dimensional situation is applicable. That is why intensity is equal to power over area of sphere 4 pi r square. Okay, So we will use tool number 2 in our second part of this problem, with the difference that we will not take 4 pi r square, we will take only pi r square. Okay, not area of a sphere, we are concerned with area of circle. Okay, tool number 3. Tool number 3 elaborates this distinction which I have already mentioned in a short pattern. Okay, geometrical shapes in 2 dimensions, and tool number 4 is geometrical shapes in 3 dimensions. Okay, in 2 dimensions, this, okay, circle area is equal to pi r square and circumference is equal to 2 pi r. Okay, while geometrical shapes in 3 dimensions, area is equal to 4 pi r square, while volume is equal to 4 by 3 pi r cube. Okay, this is sphere, this is circle, we are concerned with circle. Okay, it is enough. I think it is enough. Now this is tool number 5 is just a table in which various values of various physical constants are given. Out of these physical constants, we are concerned with the Stefan Boltzmann constant, Stefan's, yes, last row, Stefan Boltzmann constant sigma is equal to 5.76 so and so dot 10 raised to the power minus 8 Weber meter per meter Kelvin minus 4. Anyhow, dear students, actually this snapshot was on full page and it has been reduced, so I think it is visible, quite visible. Sigma is equal to 5.760400, okay, into 10 raised to the power 8 Weber per meter square per Kelvin raised to the power 4. Okay, anyhow, this value will also be given several places, several other places in relatively big font, big size. Okay, tool number 6 deals with the Weber. Okay, dear students, for the time being we are not going in detail of Weber, we are just defining Weber, and our answer will also be in terms of Weber. Here Weber is in terms of Tesla into meter square. If we discuss this Weber in detail, then definitely we will also have to define Tesla. When we define Tesla in detail, then definitely we will have to discuss. Dear students, here we are going to define Weber. Okay, the SI unit for magnetic flux is the Weber, WB. Okay, Weber, 1 Weber is equal to 1 Tesla dot meter square. Okay, we are not going to define Tesla. Okay, because if we start defining Tesla, we will also have to define ampere, gauss, etc. Okay, we 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 cannot afford to go in such other terms. Okay, so we stop it here. Okay, Weber, 1 Weber is equal to 1 Tesla into meter square. In tool number 7, it is clear, it is made clear that this symbol is sigma. Okay, sigma, sigma, sigma. This is a capital case and this is smaller case. So this sigma is sometimes also called summation. Summation means sum. Okay, sigma, summation, sigma. Okay, anyhow, okay, it is quite okay. Now we come towards the solution. We know that. What is this? This is we have applied a tool. What tool? Stefan Boltzmann law. Okay, intensity is equal to sigma. Uh, Dear students, actually sigma and rho perhaps are similar sign. I see. I here make it clear. This is rho. This is rho and this is sigma. Oh yes. Perhaps I have mistakenly used a similar symbol in place of sigma, but no. Okay, I have rightly chosen this sigma. Okay, this is rho. This is rho and this is sigma. Okay, in tool, yes. Yes, in tool, correct, sigma is given, but in our explanation, which I have typed on math type software, I have mistakenly, dear students, used the symbol rho in place of sigma. Actually, rho and sigma are to some extent similar. Okay, so this is a minor mistake. It is quite I can still during this recording of video I can change it. Okay, but it will take time. I do not afford this wastage of time. Okay, intensity I is equal to sigma T raised to the power of 4, absolute temperature power 4. Okay, not rho, sigma. This is mistakenly typed rho in place of sigma. Okay, I is equal to sigma T raised to the power 4, and then sigma's value is given exactly appearing in that table, which table I have introduced as a separate tool. Okay, 5.67037 into 10 raised to the power minus 8 Weber per meter square Kelvin square. Okay, in that table actually meter minus 2, Kelvin minus 4, because all the three terms are written in the denominator. That is why. So here I have rearranged it, otherwise there is no difference. Moreover, in place of T raised to the power 4, I have used the value of absolute temperature 1650 Kelvin. Okay, so dear students, this Kelvin 4 K4 will be cancelled out with this K4, and we will be left with Weber over meter square. Okay, Weber over meter square. Hence our answer becomes in shape of Weber per meter square. Remaining is only simplification of the expression. Okay, what simplification? Actually, first we have taken fourth power of this. Okay, 1650 into 1650 into 1650 into 1650, or we have taken its square twice. Similar thing. Okay, this figure comes. After this figure, we have converted into 10 to power plus 8, then 1 2 3 4 5 6 7 8. Okay, after 74 120, we have placed decimal here, so that it has been converted into 10 to power plus 8, and hence 10 to power minus 8 and 10 to power plus 8 will be cancelled, and this figure after multiplying with this figure will become this figure. Okay, in the next step we have rearranged this figure in this shape. Okay, 4.2 into 10 raised to the power 8 Weber per meter square. We can also write it as 0.42 into 10 to power 6 Weber per meter square. Okay, so it is our discretion. Okay, we know that radius is equal to diameter by 2. Diameter is given as 1.00 millimeter, and so its half will be 0.50 millimeter. Moreover, intensity I is equal to P over A. This has been, we have used this, which we have introduced in a tool. But in that tool, in place of 4 pi r square is given, but here we have denoted it by A. Okay, this implies that P is equal to I into A, is this is equal to I, and in place of area we have taken area of a circle pi r square. Okay, pi, oh yes, sorry, pi, yes, no mistake, yes, no mistake. We have used the value of I, which we have previously. Okay, I is equal to 4.2 into 10 to power 5 Weber per meter square. Okay, 4.2 into 10 to power 5 Weber per meter square. Okay, in place of I we have used 4.2 into 10 to power 5 Weber per meter square, into, in place of pi we have used 3 by 4, 3 by 4. Okay, dear students, we know that pi is a 22 by 7. 22 by 7 is a pi. It is perhaps called transcendent number. Anyhow, this is a basically topic of mathematics, transcendental number. Anyhow, okay, 22 by 3 is equal to 22 by 7. 22 by 7 is equal to 3.14. Here once again we express that decimal representation of pi is non-repeating, non-terminating. Okay, 3.14, and it goes endlessly. Okay, most modern computers have tried to find its value to many decimal places, and it has been still observed that its value goes endlessly. It is a non-terminating and non-repeating expression. Okay, so this is a separate discussion falling within the scope of mathematics. But that decimal representation of pi, that is 22 by 7, has a decimal representation which is a non-repeating, non-terminating. It goes endlessly. Okay, so after simplification, intensity I becomes equal to 0.3297 Weber. Okay, Weber. So this is the end of our problem. Till next problem, Allah Hafiz.